Your bank offers to pay you 10% interest at the end of every year forever. And let's say you have $100 and you decide, okay, you're going to put that $100 in the bank. So you give up $100 today. That's at time 0. And in 1 year, you get $10. And in 2 years, you get another $10. And in 3 years, you get another $10. And that goes on forever. So what's the present value of $10 received at the end of every year forever? It must be $100. That's what it's costing you. Well, let's take a look. Let's discount those cash flows and see what we get. The present value of $10 received in 1 year is $10 divided by 1.1. The present value of $10 received in 2 years is $10 divided by 1.1 squared. And the present value of $10 received in 3 years is $10 divided by 1.1 cubed. The present value of this stream of cash flows is equal to, let's put in C. Use the letter C for the $10, how much you're getting each at the end of each year, and 1 plus R, which is the interest rate. That's the first year, plus C divided by 1 plus R squared, plus C divided by 1 plus R cubed, and so on. Well, that's an infinite series. And let's multiply both sides by 1 plus R. You get 1 plus R times the present value equals C plus C over 1 plus R plus C over 1 plus R squared plus C over 1 plus R cubed. And so if you look at these two equations, you see that the bottom one is the same as the top one plus this C. So let's subtract the equation 1 from equation 2, and we'll get 1 plus R times PV minus PV equals, all of these terms here are going to cancel. It's going to equal C. And if you simplify that, well, let's do it. 1 plus R minus 1 times PV equals C, or PV equals C over R. And that's the formula for the present value of a perpetuity. Let's put in our numbers from above. We had C was $10. That's how much you were getting at the end of every year. And the interest rate was 10%, or 0.1, and that equals $100, which is exactly what it cost you to get $10 every year forever. A growing perpetuity is a perpetuity in which the amount you receive at each period is growing at a constant rate. For example, let's let R be our interest rate and G be the growth rate, the rate at which the perpetuity is growing. So at time 0, we'll have the present value times 0. At time 1, you're going to receive C, and at time 2, you're going to receive C, and it's going to grow by G. So, and at time 3, you receive C, but it's now grown by 1 plus G squared, and so on. So how would we calculate the present value of that? Well, we're going to want to discount by 1 plus R and by 1 plus R squared, 1 plus R cubed. And so the present value is going to equal C divided by 1 plus R, C times 1 plus G divided by 1 plus R squared. And again, we have an infinite series. It takes a little bit more algebra to solve this series. But the solution is that the present value of a growing perpetuity is equal to C, which is the first cash flow, divided by R minus G.